Absolute value inequalities. Again, we can think of absolute value in the following fashion. We defined it before in a previous video, that if we say that the absolute value is equal to 7, for example, then we can say that this absolute value means that x will be somewhere equal to 7, or it could also mean that it's equal to negative 7. However, if I have something like absolute value of a is less than 5, for example, that means that the distance between 0, the x will be the distance between 0 and 5. So it'll be somewhere between 0 and 5, or between 0 and negative 5. So it will be this distance, somewhere in this distance. But it doesn't mean that it's equal to, so we have to exclude the points at the two ends. Or we can write it as x is less than 5 but greater than negative 5. This is in inequality form. However, we can always write it in another notation. We can say negative 5 here, and it goes all the way to positive 5 there. The parentheses imply that x is not equal to the endpoints, in other words, being 5 or negative 5. Suppose I have, however, the absolute value of y is greater than or equal to 4. Well, in this case, again, absolute value implies that y will be somewhere beyond 4 or equal to 4, or somewhere beyond negative 4 in that direction. I include the two endpoints in this case because it has an equal sign underneath, so we can say that y is greater than 4, or y is less than or equal to negative 4. Now, when I have something a little more complicated, say you have the absolute value of 2x minus 5, like this, and this absolute value is less than the value 3. Again, this, we can think of it as that this quantity here will be somewhere between 0 and 3. Notice I said the word quantity, not x, and negative 3. So this x will be smaller than 3. This value of this quantity is smaller, somewhere between 0 and 3, and 0 and negative 3. Now, what is the value of x that makes this true? Well, in this case, you will have to set it up as 2x minus 5 is less than 3, which is greater than negative 3 on the left side. This should be a negative 3 here. And then if we solve for x in the center, we would have to add 5 to all sides. Notice that I have here, here, and here. So this would be 5 take away 3. It was 2, less than 2x, which is less than 5 plus 3 is 8. And if I were to get rid of this 2, I want to isolate the x. I divide here by 2, there by 2, and over here by 2. This will give us 1 is less than x, which is less than 4. Now, if we were to graph the solution set for x on the number line, then we would say that x is in between 1 and positive 4. Here's 2, 3, and 4. So this will be an open circle here, an open circle there, which means that x will be somewhere in between here and there. Notice the difference between the value of x and the quantity. This was representing the quantity of 2x minus 5, the absolute value of. So this was the distance of the quantity, whereas this represents the value of x. Let's take one example which is a little more complicated, but not overly complicated. Let's say I have the absolute value of 3a plus 7 is less than or equal to positive 4. Again, this quantity will be somewhere between 0 and 4, and then 0 and negative 4. So we can rewrite this as 3a plus 7 is less than or equal to positive 4, or greater than or equal to negative 4. Now we can solve this inequality in the same fashion. We can subtract 7 from all sides, like so. And of course this will give us a negative 11, less than or equal to 3a, which is less than or equal to negative 3, I believe. And dividing everything by 3 will give us negative 11 thirds, less than or equal to a, which is less than or equal to negative 1. And then we can graph the value of a on a number line. So if we take a number line, for example, let me draw a line real quick. I'll just do it freehand here, like so. And then we say, all right, well, negative 1 will be somewhere over here, 0 will be somewhere over there, and then negative 11 thirds will be to the left of that. So let's say it's roughly there, negative 11 over 3. Then that means that we put a closed circle here and a closed circle there. A must be less than that, and a must be greater than or equal to this number here. So that would mean that a is in between this value, negative 11 thirds, and negative 1. So I can include all the in between. Now, there are cases where you would have suppose you have a case where our inequality was greater than or equal to, say I have 4x minus 3 is greater than or equal to 9. Now in this case, if we use the number line to think likewise, we say that this quantity will be somewhere between 0 and 9, but it will be greater than somewhere in that side. Okay, we're thinking quantity here, remember that. Over here, we said, okay, well then this quantity will be somewhere between, larger or less than negative 9. So I'm going to put an open closed circle there, and it'll be somewhere over there. These are the quantity we're talking about. Now, for what values of x will make this true? Well, this is where you have to say, all right, well then we can say over here, we can say 4x minus 3 is greater than or equal to positive 9. On the left side, I can say 4x minus 3 is less than or equal to negative 9. And then we can solve individually. Over here, I will get 4x is less than negative 9 plus 3. That gives us 4x is minus 9 plus 3 will be negative 6. And then divide both sides by 4. Divide by 4. Which gives us a fraction, which is less than or equal to negative 3 over 2. On the right side, we would have add positive 3 to both sides, plus 3 like so. And 4x is greater than or equal to 9 plus 3, which is 12. And 4 goes into 12 nice and evenly. So x will be greater than or equal to positive 3. And then on the number line, you can actually just graph the solution for x, which is different than the solution we have up here, which was a representation of the quantity of the absolute value. Here is a representation of our x values. So then x will be somewhere between, let's see, 1, 2, and 3. Put an open, close circle here. And it says that x must be larger than 3. So we're going to have to write an arrow pointing to the right. So it will be all values of x which are greater than or equal to 3. And then on the left side, we're going to say, okay, here's 2 halves minus 4 halves, which is -2. So somewhere here will be our value of -3/2. And of course, our arrow would point to the left side, which means that x will be any value less than or equal to -3/2. And there are two special cases where you have to be careful, and those are when you include something of the sort. Suppose you have the absolute value of 7x minus 1 is less than -2. Well, for this absolute value, this distance, since the absolute value can never be negative, then no matter what x you choose, there will be no solution here, because let's say I pick 0. 7 times 0 is 0. The absolute value of 1 is positive 1. Clearly is not less than -2, so that wouldn't work. So no matter what value of x I choose, this will be no solution. So I can use this thing called the null set. So there's no solution here. No solution. Since distance is always positive, it can never be negative. Definitely, a positive value will never be less than a negative value. Also, if you have something of the sort, say you have 6a plus 2, absolute value, which is greater than a -5. In this case, no matter what value you choose for a, let's say you choose 0. So the absolute value of 2 obviously is bigger than 5, or -5 rather. Now, if I choose a negative value, it doesn't make any difference because the absolute value of that will still be positive. And any value, in fact, any value of a, will make it true. Will be true. In other words, this is true for all values of a. Okay? True for all a. And it doesn't matter whether it's positive a or negative a, because a positive value is always greater than a negative value. I hope that helps.